An epoxide contains a three-membered ring, one component of which is oxygen. A prototypical epoxide is this one. The IUPAC name is oxirane, and the common name is ethylene oxide. Again, numbering starts from the heteroatom, which is oxygen, and other substituents, if there are, will be located accordingly. Ethers are formed from alkenes with peroxy acids such as magnesium monoperoxyphthalate and MCPBA. This is the structure of monoperoxyphthalate without the magnesium. You are already familiar with MCPBA. For example, MCPBA can allow the ready formation of an epoxide from an alkene. Because the alkene has a flat feature, the epoxide may form on either side. This bond is drawn downwards. But an isomer can also be formed wherein this bond is oriented upwards. Now, an epoxide is more reactive than regular ethers because of ring strain. Protonation of this oxygen in acid can lead to this species in the presence of water. Water attacks the more substituted carbon in an anti-manner. This is because the electronegative atom, which also holds a positive charge, would be strongly electron withdrawing, and a positive charge at this position would be more preferred. Finally, the proton will be taken by the solvent to remove the positive charge and form the 1,2 diol. In summary, in unsymmetrical epoxides, the nucleophile attacks primarily at the most substituted carbon of the epoxide following protonation of oxygen. The ring opening is stereospecific. It means that the starting material here, the epoxide, dictates the orientations of the hydroxy groups of the product. Because the reaction involves an inversion of configuration, if this is downwards, the hydroxy group here will be oriented upwards. The outcome of stereospecific reactions depend on the stereochemistry of the starting material. In the case of basic conditions, with bases acting as strong nucleophiles, these include Grignard reagents, attack on the epoxide occurs at the less sterically hindered carbon, here. Thus, if you have a methoxide, your methoxide will attach at this point. This bond will break to deliver this product. As you see, the orientation of this oxygen remains downwards. Again, this is a stereospecific reaction. To remove the negative charge, we need to have an acid workup to form this alcohol. Note the difference between an acid-catalyzed ring opening and when bases are used. The internal hydroxy groups are oppositely oriented.